Okay, today what we're going to do is look at converting within the metric system. Last day we looked at the different names for all the units of measurement, and today we're going to look at converting in between them. The distance from the Earth to the Moon is 38,440,300,000,000 centimeters. This is an incredibly large number. But the other thing that really jumps out is that the unit of measure does not seem appropriate. Centimeters does not seem like a nice unit to be talking about when you're going so far. And in this particular example, maybe a better unit of measurement would be the kilometer. Now, when we convert in between units of measurement in the metric system, what we're going to do is we're going to look at two methods. Method number one is bouncing along the unit line. You may learn to multiply like this in elementary school. It's a nice method, it's pretty straightforward, and it always works. In doing this method, all you really have to worry about is where you start and where you finish. And know that as the metric system is based on multiples of 10, we're going to either multiply or divide by 10s. But the key thing here is you got to know your units, at least from millimeters all the way up to kilometers. And as soon as you know that, what's really just happening then is you're bouncing along a number line. Your brain really likes this. Really straightforward. When we go from right to left, we're going from a bigger unit to smaller. And as we go from bigger unit to smaller, whenever we go in this direction, we're going to multiply by 10. When we go from the left to right, we're going to be going from a smaller unit to bigger. And we start bouncing along the number line, we're going in the opposite direction, so we're going to do the inverse operation, and we're going to divide, again, just by powers of 10. So that's what I mean by bouncing along a unit line. The other method we're going to look at is probably what your science teacher really wants us to look at, unit analysis. Again, start and finish is important. You have to know what unit you have and where you want to finish. What we're going to do in this one is we're always going to multiply by the conversion factor. And again, the need to know in this one is the basic conversion factors. So for instance, there's 10 millimeters in a centimeter, there's 100 centimeters in a meter, there's 1,000 kilometers, or there's 1,000 meters in a kilometer. So our general idea then is we want to be aware of the unit you start with, and the unit you want to finish with, and use conversion factors to eliminate unwanted units. Okay, so we'll do a couple of examples using both of them. Ultimately, what you want to be able to do is to figure out which one you like best, which one makes sense to you, and then go ahead and do it. Okay, so again, in this one, we want to convert 100 millimeters to centimeters. You should know this right off the top of your head, but here's this idea of the unit line. I'm not going to fill all these things in because we really don't need them. But here's this idea. First of all, again, you know your units, you know what order they go in. Our second idea is we want to know where we're going to start and where we want to finish. And in this case, here it is right here. This is my start and here's my finish. And what ends up happening is I'm going to make one bounce to the right. As it says in our notes above, whenever we bounce to the right, every bounce to the right is a division, and it's always a division by 10. So when using this bounce along the number line, I start at 100 millimeters, I make one bounce to the right, so I'm dividing my 10, I end up with 10, and of course, those are centimeters. And other than me writing centimeters at the very end, notice I didn't even bother with units in my calculation. They're in my picture. So that's one really nice thing about the unit line. Okay, with unit analysis, you have to write in your units. So again, it's the same idea. We go, okay, where do we start? Well, I start with 100 millimeters. Now I'm going to leave it blank. And where I want to end up with is centimeters. And I want to know how many ultimately. So there's that idea in our notes. You have your start, you have your finish. And in that blank, besides 100 millimeters, we're going to multiply by a conversion factor. Now, the two things happen with the conversion factor. It gives us, the relationship between the units, but it also eliminates unwanted units. The unwanted unit is millimeters. So I need to find the conversion factor between something and millimeters that gets rid of the millimeters in this case, and I want centimeters left over, so I have to look for this one. What's the relationship between centimeters and millimeters? And we know that 1 centimeter is 10 millimeters. Now when you go ahead and do this calculation, notice we're multiplying fractions, if you want to think about it that way, and we end up with 10, 100 times 1/10, and what happens is, in this unit analysis, millimeters cancel out. It's kind of like a common factor, something in common, top and bottom, like when you simplify fractions. So when the millimeters cancel out, I'm left over with what I want. That's a really straightforward one. There's one conversion in there, and the conversion we know, or we should know. Okay, let's get back to that huge number we started with. If we're going to do a unit line, what we're going to do is, well, here's my start. There's my start right there. And where I want to go is, I want to go to kilometers. In this question, my finish. And I'm going to bounce once, twice, 3, 4, 5 times. So if we're doing this calculation with our calculator, it would be pretty easy to do. Now remember, every time we make a bounce to the right, we're dividing by 10. Every single time. So as it says in our notes, unit line method, we have our start, and our start is that absolutely huge number. Don't really care about the units. And what I'm going to do is, I'm going to divide by 10 once, twice, 3, 4, 5. And when you just do that on your calculator, you end up with this number. 384,403, and then we have to know that, well, those are kilometers. So again, we really didn't think about the units, but the units are on our number line. That's why it's valuable to do it this way. The other thing I think you guys should know is when you divide by powers of 10, or you divide by, every time you divide by 10, you move the decimal place one place to the left. So if you started off with our original number and you moved the decimal place to the left 5 times, all of those zeros at the end of that huge number would go. So that's the idea with with the unit line, bouncing along a unit line. But again, your brain really likes pictures. That's a really nice picture. And remember, no units. Okay, unit analysis, we do have to include the units. So I'm going to write that really big number, 440 billion, 300 million. And again, I have to write centimeters. I'm going to leave a big space in the middle, and I know I want to end up with kilometers. Now we're going to multiply by the conversion factor. Now, off the top of my head, I don't know a conversion factor between centimeters and kilometers. But I know I have to get rid of centimeters. And the way I could do that is put centimeters on the bottom in this unit analysis. So now I have to come up with a conversion factor that I do know that's nice. And I do know a really nice relationship between meters and centimeters. 1 meter as 100 centimeters. Now that's great. If I were doing my unit analysis, the centimeters are going to cancel out, and I'd be left with, I don't know, however many meters. But again, the whole problem is I don't want meters, I want kilometers. So what I'm going to have to do is I'm going to have to get rid of meters using another conversion factor. Now, if I want to get rid of meters on the top, I need meters on the bottom. And here's where I do know a nice relationship between meters and kilometers. 1 kilometer has 1,000 meters. And again, with our unit analysis, the meters cancel out. And as we march along and do our multiplication, there's only 1 unit left, and it's the one I want. And when you go ahead and do that really nasty looking calculation, but again, hopefully if you can't do it in your head, you have a calculator handy. There you go. Again, your science teachers like this, they want this. It's a valuable thing. So there, really quickly, is a way of converting within the metric system. Again, if we summarize the key ideas for this lesson, then it comes down to knowing your conversion factors if you're going to use unit analysis, or, and I guess either one, knowing the SI, units of measurement. Like basically, where are they relative to one another?